TouchDesigner is an amazing tool to create live visuals, but that's only really useful if you can actually, display them somewhere. So this video is going to cover a bunch of different ways to take video and send it out of TouchDesigner, as well as taking video from other places and pulling it into TouchDesigner. There are a few different categories of techniques that each have different types of capabilities. Local techniques are by far the best option, but they only work between different processes on the same computer. Network techniques are more flexible and can go between different machines, but they can have issues with latency and compression. And finally, hardware techniques can be really flexible and powerful, but might require buying physical devices. From a TouchDesigner network perspective, nearly all of these are basically the same. It's just, a top that you stick at the end of a network and feed video into it, and it goes somewhere. The first one is a local technique, or rather a pair of techniques that on Windows is called Spout, and then on Macs is called Syphon. They're effectively the same thing, and TouchDesigner even uses the same operator for both of them, just called the Syphon Spout top, and it just uses whichever one is supported by the OS. They take the incoming video and copy it into an area of the GPU's memory, and then another process on that computer just copies it out of that same memory. So they are by far the fastest option, but they have to be two different processes on the same computer with access to the same GPU. On the plus side, there's a ton of other software that can send and receive Spout and Syphon. Resolume, OBS, VDMX, MadMapper, all of these ones support whichever one is supported on the OS. If you want to get video between TouchDesigner and any of those other programs on the same machine, or even between one instance of TouchDesigner and another one that's running on the same computer, then this is going to be your best option. To use this technique, you would create a Syphon Spout out operator, and you need to give it a name. So we can just call this stuff, and then other processes on the same computer will be able to see that. So here we have another instance of TouchDesigner. So if we create a Syphon Spout in, then in the drop-down menu here, we're going to see that name that we created, and we get a live stream of video going between those two processes. Or if you're using Resolume, then as soon as you set this up and it's set as active, then it's going to show up in this list here, and you can just drag it into any composition and it's going to come through. Similarly, in Resolume, you can switch on that kind of output. So if we had something else going on here, then over in TouchDesigner, we can see arena composition, and that's going to come through right there. The names that you use for these Syphon and Spout streams have to be unique on that computer. So if you were to have two of them, then you're going to get an error on the other one. And even if we used a name from a different piece of software, but running, in TouchDesigner here, then we're going to get an error there. So it's going to say that this name is already in use. So the pros for this are it's really, really fast and it's totally lossless. The cons are that it can only be on the same machine between two different processes, and that's it. But that's a big limitation depending on what your setup is like. The next technique are the touch in and touch out tops. So we create one of those here. And then in another touch process, we create an input, and it will come through there. This is similar in some ways to Syphon and Spout, but instead of just going directly through GPU memory, it goes over a network. In the sender, you have to pick a port that it is available on, and then on the receiver, you need both the IP address, which could be the same computer, and the port. The port that you use is kind of arbitrary. I tend to stick with ones that are like, 5,000 and higher, because those I think are typically used less, but as long as it's not being used by something else, then it should work. One of the nice little aspects of this is that the sender can tell whether something is listening. So in case that for some reason is relevant, then this might be a good option. This technique is made specifically by Derivative for use in TouchDesigner. So no other software is able to use this. And because it's using a network, it can have latency. So that's always going to be a risk. Although if it's between processes on the same computer and it's just going to like localhost, then usually that's not an issue. If it's between different machines, though, it can use up a lot of bandwidth depending on the resolution, the pixel format, and the codec that you choose. On the touch out top, you have a few different options for the codec. There is uncompressed, which sends literally every pixel like exactly the same as it went in, shows up exactly that way on the way out, but that can use up a lot of bandwidth. Then there are two different types of compressions. There's HapQ and HapQ alpha. These have some compression, so there is like a little bit of a loss of quality, but they're not too bad. And if you've ever rendered out Hap as like video files, then you'll know that those files are massive. So it does mean that, it's still going to take up a decent amount of bandwidth, even though it's going to be less than uncompressed. If you're using this technique, it's often a good idea to have like a dedicated network switch just for that. So you would have, two different computers and a switch, and they each are plugged into that, but you don't run anything else through that switch. So a lot of computers will have, especially desktops, will have multiple network interfaces. So, they could plug one out that goes to the internet or something, and then each one just has one dedicated to that switch there. That way you don't have to worry about anything else taking up bandwidth on there. So the pros of this technique are that it can go between machines and it can be lossless if you set it up that way. The cons are that it only works when in TouchDesigner on both the sending and the receiving end. It can use a lot of bandwidth and it can have latency, and you have to deal with keeping track of IP addresses and port numbers and all that, which can be kind of a pain. Next up is NDI, which is another network-based technique, but this one is a standard that's supported by lots of different software and even a bunch of hardware devices. To use this technique, you would create an NDI out top, and then on the other end, you can create an NDI in. Similar to Spout and Syphon, these streams have a name. So if we called this, ASDF or something, and on the other end, there's going to be this drop-down menu. And because of how it handles those names, then the names need to be unique on the same computer. So if, we were sending to two different things with the same name, then that's going to be an issue. But if you have two different computers on the network, then they can use the same name because on the receiving end, it adds the name of that computer. So it'll make them unique. So that kind of like automated discovery thing can be really, really useful in a lot of different situations. But the huge drawback of NDI is that it can use compression and you don't have as much control over when and whether it does that as you do in touch in and out. In many cases, NDI will automatically adjust the amount of compression based on how long things are taking to get across the network, which is kind of nice in that, it automatically manages that, but at the same time, that means that you may not be able to tell it not to compress. And even if it has chosen to use compression, then it's still going to require a decent amount of bandwidth. If it's on a dedicated network, like we're talking about with touch in and out, where you have a switch that's, just for NDI stuff, then that can be okay. But if you have a lot of other stuff going on in the network, it can be a problem. NDI can also be a little bit unreliable or sometimes can behave a little strangely. There can be cases where for some reason, you might not see certain computers that are on the network from some places, but other places might see things, or we've had issues in our studio where one side can see that there are NDI streams, but can't seem to actually get the video from them. So there occasionally can be some kind of mysterious issues with it. It might be theoretically possible to send NDI over the internet, but I don't think I've ever heard of that working. So typically it's just going to be going on a local network. There are a lot of different devices that support it, including coders and decoders and mixers and cameras and Wi-Fi transmitters and video players and all sorts of stuff. So you can sometimes have, a computer on one end and, a webcam on the other that's just transmitting NDI and, the computer listens to it. Or you could, be transmitting it from a computer into a Wi-Fi transmitter that goes off to, some other device. And so there's a lot of different options for configuring it if you have that kind of hardware on hand. The pros of NDI are that it can go between different machines. There's automatic discovery of sources. It's widely supported by lots of different software and hardware. The cons are that it might compress and you don't have a lot of control over that. It can use a lot of bandwidth. It can have latency, probably only works over a local network, and sometimes it can behave a little unpredictably. Next is a technique, or rather a set of techniques that use the video stream in and out tops. So these are designed to go over the internet, and they can be used to live stream to Twitch or YouTube or lots of other places like that. They support a few different kinds of protocols like RTSP, RTMP, SRT, and so on. Since these go over a network and frequently over, the internet, there can definitely be latency, and that latency might be significant depending on the kind of connection that you have or whatever's going on at the other end. So there might even be like several seconds of delay there. It supports H.264 and H.265 compression, and you have a lot of different control over how much compression gets applied. So you can kind of tune that to the scenario and the conditions that you're in. If you notice that things are lagging a lot, you could add more compression or something like that. It's not a good option for sending uncompressed video, although generally speaking, sending uncompressed video over the internet isn't really a viable option, at least with, current internet infrastructure. Setting it up can be a little bit tricky too, where you need to have a URL that it's sending to. So generally, when you're streaming like that, whatever you're, sending it to, like Twitch or something, is going to give you a URL that you paste in, and it'll listen for that. And there's often some kind of like security stuff in there to make sure that you're authorized to stream to that. But once you get it set up, it'll just continue, sending out video stream to Twitch or wherever. TouchDesigner supports video streaming in and out, so you can use it to receive video across the internet too, if you set it up properly. So for streaming, the pros are that it can go across the internet. It's supported by streaming services like Twitch. The cons are that there can be compression. There usually is compression. There can be latency, which can be like pretty significant, and you have to deal with configuring it all. But if you want to be live streaming something to the internet, this is basically your only option. The next technique requires hardware, and it's by far the most commonly used one. It's display outputs. This may sound obvious, but it's worth discussing it relative to the other options. Your GPU has some ports on it that you can connect a cable to, HDMI or something like that. When you connect it up, the operating system is going to notice that something is connected there, and typically it will treat that as it does any display, which could mean, showing windows and cursors and taskbars and that kind of thing on there. To use this kind of output, you would create a window comp. So this is one that's a little bit different from the other techniques that we've discussed so far that all just involve a top. So on the window comp, there's this window operator. You can drag any top there, and it will put that into the window. And then to open it, you can use this open separate window, and it will pop up somewhere on one of your displays. And you can typically drag that around. You can use this monitor setting to tell it which display to go on. But at least in my experience, this can be not necessarily intuitive. So typically I'll end up picking one, and if it's the wrong one, setting it to the next one, just kind of stepping through them to find it. To make this go full screen, you would switch off this border setting, and it will stick it onto one of your displays, and you can choose where on the display it goes, or if matches the resolution of that screen, then it would fill the whole area, or you can tell it to fill the whole thing. This can get you into situations, especially if you are selecting between monitors, where you block the user interface and you can't change monitors. So with that, you would just hit the escape key to get out of it, change the monitor setting, and open it again. Even if you're displaying it like this, where you have, a borderless window and it's, full screen or something, the operating system is still able to put things on top of it. So, a mouse cursor is showing up on top here, or, another window might pop up and cover part of it. Or if you're doing, Alt Tab or something on Windows, or, one of the gestures on Mac, like it might rearrange the contents of that window and you may have no control over that. So control is really the main issue with this kind of approach. But it is, completely lossless, no compression, and the resolution is just limited by what your GPU and the device on the other end can handle. So, a monitor will have a maximum supported resolution. So a monitor will have, maximum supported resolution or something, and, your GPU, if it can handle it, can send that much, and it'll come out exactly as it went in. So, no data loss between those two. The pros of this technique are that, literally every computer supports this. Projectors, monitors, all that stuff can handle it. There is no compression. It's effectively instantaneous. But the cons are that the operating system might decide to show other stuff on there, or it might even, move things around. It only goes between a computer to, a device that can receive it, like a display, and it requires a physical cable going, all the way from one end to the other. There's an alternative that was recently added in TouchDesigner called direct display output, where it sends video to a port on your GPU. But unlike with, window comps and all that, it fully takes over that whole display and sends controls every pixel going through. It's basically instantaneous and it's lossless, but there are some significant limitations. It requires running on Windows Pro or Enterprise. So, your laptop may well not support it. And if you're on a Mac, definitely not supported. It requires a professional grade NVIDIA GPU like an A5000. Even the fanciest of the consumer grade GPUs like a 5090 can't handle it. But if you do meet those requirements, it can be really powerful. So the pros are that it's uncompressed, you have total control over everything that goes to it. But the cons are that there are really strict requirements of what supports it. And you still have to deal with, physical cable connecting the computer to wherever it's going. The next hardware option involves a device called a capture card. These are often PCI cards that slot into a motherboard for a desktop, but there are also some really great ones that use USB-C or Thunderbolt 4 or whatever slight variations of that exist now. They'll have one or more input ports, typically HDMI, but sometimes other things like SDI or DVI. From the perspective of the computer that's receiving it, the one that, the USB cable is plugged into, it's going to show up just like any webcam input would show up. But instead of showing camera input, it's going to show whatever video is coming in through the HDMI cable. And from the perspective of the computer sending, then it's going to show up just like any display or projector output would. They do require physical cabling, and they can actually have a little bit of latency in there, typically a millisecond or so, but they're almost always uncompressed, except for, really sketchy, suspiciously priced ones that you might find on eBay or something. The amazing thing about capture cards is that they're supported by any software that can use a camera inputs. That, includes TouchDesigner, but also includes Resolume and OBS and even stuff like Zoom or Microsoft Teams or, any software that can use a camera can use a capture card. The consumer grade USB ones are generally pretty decent. I've used Magewell a lot. They typically start around 300 US for a 1920 by 1080 one that can handle, 60 frames a second. Higher resolutions are going to cost more. There are also a whole range of them that are intended for professional use that support numerous inputs and, SDI and all kinds of other stuff. Those can get pretty costly, but typically in scenarios where you would need that kind of capability, then, everything is costly. But even if you're just using one of these USB ones, they're a pretty good option for sending video from one computer to another. You can just have two laptops sitting next to each other with, HDMI coming out of one, going into a capture card, going into the other one. And that can be pretty easy to set up, and it's pretty flexible. The pros of capture cards is that they're widely supported, they're almost always uncompressed. The cons are that it still requires physical cables. There are resolution limits based on whatever the hardware supports, and there can still be a little bit of latency. And if you're going for the higher grade ones, they can get pretty costly. There are also similar devices called output cards. They're basically like a reverse capture card where you connect it to a computer by USB or into a PCI slot, and they'll have output ports like, HDMI, DVI, SDI, all that. But you may be thinking, my computer already does that. Like my GPU already has HDMI outputs on it. Why would I want a special device just to do the same thing? The answer to that is control. When you connect an output card to a computer, the operating system doesn't really see it as a display output at all. So you can't move Windows onto it. The mouse cursor is never going to show up there. It requires software to specifically support that kind of device. TouchDesigner supports a few different brands, including Blackmagic. Software like Resolume and OBS also support a range of different kinds of output cards. But mostly these tend to be more professional grade equipment, which can mean that they can be costly. Many higher end capture cards, especially the PCI ones that you're, slotting into the motherboard, will often have a number of different ports that you can switch between being either input or output. And those are really great in, higher end production scenarios where you have, several incoming camera feeds that are plugged in via SDI and then an LED wall. And like all of that can be running through specialized output hardware. These devices are also critical if you need gen lock, which is mostly relevant if you're dealing with high grade production hardware for, film shoots or dealing with large LED walls. The pros of output cards are that you have total control over the output. It's uncompressed. It's widely supported on the receiving end because, it just shows up like whatever can go through HDMI or SDI or anything like that. It supports gen lock if you have hardware that needs that. The cons are that it can be costly and it still requires physical cables. And depending on the card, they can be pretty specific about which resolutions and frame rates they support. There are also some more obscure ones that I didn't cover, like DirectX and RenderStream. And there's ST2110, which is available in the latest TouchDesigner experimental release. It's similar to NDI, but different in ways that video nerds will have strong opinions about. I haven't used it a lot, but I think generally speaking, it's a similar approach of sending video over a network with, some amount of compression. Different techniques make sense in different scenarios. If it's between programs on the same computer, if you can get away with using Syphon or Spout, do that because it's always going to be better than any of the other options. If it's two instances of TouchDesigner on different computers on a fast network, then the touch in and touch out can be a good option. If it's between other software on different machines on a network, or you want it to be easy to automatically find available streams, then NDI can be a good option. If it's going over the internet, it probably has to be streaming, SRT, something like that. If it's between computers that are physically near each other and there either isn't a fast network or you don't want to use it for some reason if it's being used for something else, then you can try using a capture card with, regular monitor output from the other end. Or if you want really tight control over, what goes to that output, then an output card on the sending end might be a good option. If you've made it this far in the video, congratulations, you now know at least the basics of a bunch of different ways to send and receive video. It's a lot of information to take in, but it can be really handy to know what options are available so you don't, waste time trying things that aren't going to work out. If you like this video and you want to support me making more of them, consider subscribing to my Patreon. You'll get exclusive downloads, early tutorial access, a bunch of RayTK stuff, and more. And even if you don't feel like paying, you can subscribe for free as a way to get RayTK announcements and tutorial announcements and that kind of thing. Thanks for watching, and make sure to like, subscribe, and turn on the notification setting.